Dear students, again your maths teacher. So this video we are going to continue with some examples of relations on the set of natural numbers. Let R be the relation defined by x related to y if x plus 2y equal to 21. Okay, so this is your question. Your question ends here. So what will be your R elements? You have to substitute x and y to satisfy 21. So if I am taking x equal to 1 and y will be 10, so it is 21. Like that, x is 3, okay, x is 3 and y is 9, so 18 plus 3 becomes 21. Like that, 5 plus 16 equal to 21, 7 plus 14 equal to 21. So that you have to find yourself, right? So this is some idea. So you can ask me how I can find these numbers. Randomly you select x equal to 1. It will be 2y equal to 21 minus 1. So 2y becomes 20, y becomes 10. And then x is equal to 2. You will be getting 2y equal to 21 minus 2, 19. So it cannot be a number. So it's a decimal number. So like that you can select 1, 2, 3, 4 for x. You will get respective y value. So you have 1, 2, 3, 4, 5, 10 elements you have. Now I am going to check the reflexive first. I need a 1 comma 1. You can ask me suddenly how you can take 1 comma 1. Your first x value is 1. So then you have to check 1 comma 1 you have in the set or not. 1 comma 1 is does not belongs to R. Therefore R is not reflexive. So the elements of x you have to check where you have x value. The first numbers are all x values, right? So R is not reflexive because of 1 comma 1 is not an element of R. The next one symmetric. We have 1 comma 10, correct? We have 1 comma 10. So at the same time we need 10 comma 1 also belongs to R. But 10 comma 1 is does not belongs to R. Therefore R is not symmetric. So how I can check for all the numbers we need the reverse. 1 comma 10, 10 comma 1, 3 comma 9, 9 comma 3. For example, I have taken only one element. And transitive, you have 1 comma 10, but I am not taking 1 comma 10. I am taking 3 comma 9 and 9 comma 6. 3 comma 9, 9 comma 6. Then we need 3 comma 6. 9, 9 you can cancel. Actually, like this for your understanding. Okay, so these two numbers would be equal. Final answer will be the first and last one. 3 comma 6 is does not belongs to R. Then R is transitive. It's like in our proportion extremes. Okay, so what about the 1 comma 10? We don't have pair with like 10 comma 1. So if 10 comma 1 means we can continue with the third one, right? So you have to see where you have the relation 3 comma 9, 9 comma 6 you have the relation. Okay, so like that you have to check for all the elements. So here R is not transitive because 3 comma 6 is does not belongs to R. So students listen carefully. So this is your set. Okay, so for reflexive we have to see the 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. If all the numbers or elements are belongs to R, we can say R is reflexive, otherwise R is not reflexive. And symmetric you have to check for all the elements. It is only for the particular elements. This is for all the elements 1 comma 10, 10 comma 1, 3 comma 9, 9 comma 3. So R is not symmetric here. Like that in transitive 3 comma 9, 9 comma 6 it is also particular relations only. It's not for all the elements. 3 comma 6 is does not belongs to R, therefore R is not transitive. Next one of the simple formula, and that is information. Let x is equal to 1 comma 2 comma 3 comma 4. So you have 4 numbers. So what will be your Cartesian? You have totally 16 elements in your relation. But I am taking only the particular number, that is particular element r equal to pi. You know pi is an empty set, right? Pi is empty set. Now how I can define the relations, that is basic relations. The first one, as 1 comma 1 is does not belongs to R, it is not reflexive. Why? Because your R is empty set, no elements you have in your R. Therefore, R is not reflexive. But as we cannot find a pair x comma y belongs to R such that y comma x does not belongs to R. If no elements means we no need to check the symmetric. So the answer will be your R is symmetric, and similarly R is transitive. Similarly your R is transitive. Okay. So now we come to one more example. X equal to 1 comma 2 comma 3 comma 4. In Cartesian product you have 16 elements, but I have taken selectively some numbers that you can go through yourself. The reflexive, so I have 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4 belongs to R. Therefore R is reflexive. So my proof is over. I have all the 4 numbers 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. Therefore R is reflexive. Suppose the 4 comma 4 is does not belongs to R is not reflexive. It is clear? So for all the 4 numbers we need the 4 pair. Next one will be symmetric. 2 comma 1 you have. So symmetric is depends upon here. Reflexive depends upon your original universal set, right? So 2 comma 1 you have. So at the same time I have 1 comma 2 also. And 1 comma 3 you have 3 comma 1 also. So therefore R is symmetric. Like that your transitive 1 2 comma 1 you have, 1 comma 3 you have, but 2 comma 3 does not belongs to R. Therefore R is not transitive. Okay. Now one more example. 1.13 is one of the repeated 5 mark question in our first lesson. So any test in your school like midterm or whatever it is, this is one of the question you should know first of all. And the set is set of integers. Define m related to n if m minus n is a multiple of 12. You know multiple of 12. A multiple of 12 is nothing but your 12 table. You should know the 12 table. So tables also plays a very vital role in your higher secondary. So you can practice in your free time. Don't waste your time. Like how to practice tables, you know. You can write tables from the last number, you know, like 20 into 2s are 40, or 2 20s are 40, 2 19s are 38. Like that you can practice all the tables. Once you selected the max group, you have to work hard, right? So the first one will be reflexive. Your m minus m. So where you have m minus m, it is your definition of your question. You have to check the two numbers difference is a multiple of 12. So I am finding with one number m minus m equal to 0. So 0 is a multiple of any number. It can be multiple of any number. 0 equal to 0 into 12. Therefore m is related to m. That is R is reflexive. Like that symmetric, m related to n, then m minus n equal to some multiple. It can be 12 or 24 or 36. So it depends upon your k values, right? So m minus n equal to 12k. I am taking minus as a common factor. It will be n minus m equal to 12k. n minus m equal to 12k. So that minus we can take it to the right side. It will be n minus m equal to minus of 12k. Hence n is related to m. This is related to m. You have to understand this is R. Therefore R is symmetric. Okay. It will be transitive. Let m related to n and n related to b. Then m minus n equal to 12k, n minus b equal to 12l. These two are independent. You can select like a and b also. That is your choice. When you are adding minus n plus n cancel, you will be getting m minus b equal to 12 times k plus l. This is a process of to finding the relation. So you just add or subtract, it depends upon the definitions. So m related to b, therefore R is transitive. Thus R is an equivalence relation is one of the 5 mark question. And the exercise, the last question also the same type of question in terms of division, right? So that you can practice or you can have in the next video. So you have to complete this all in your notebooks. Thank you, students.